All right, so for problem number 19, it says planet distances in order for 2012. The question says, let's look again at the pattern and the location of the planets in our solar system as seen in the table 18. So I got that right here. We'll look at that in a second. It says, re-express the distances to create a model for the distance of the sun based on the planet's position. All right, so yeah, to create the model, we are going to have to crank through and do some math, though. So, and then let me read part 2. It says, based on the model, would you agree with the International Astronomical Union that Pluto is not a planet? Okay, so they're using statistical data to kind of show that Pluto is not a planet. So let's look at the data. This is the data. So this is the planet. This is the distance from the sun. And it says, in problem 18, it says plot the length of the year, blah, 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 blah. But basically, we're going to compare the position number to the distance, all right? And then see if there's a linear model. And go from there. So the association between the planetary position and the distance from the sun can be strong, positive, and curved. So if I were to, I'm not going to plot it, but I'll just take a little photo of it. So if we were to plot this data, just for time's sake, okay? Let's plot it. Let's go ahead and plot it. So let me turn on my calculator because it's good practice for you guys to see it. Give us a second. Pay attention. In fact, if you have your calculators, go ahead and pull them out. I'm going to show you a bunch of stuff on the calculator. It's always helpful to practice with your calculator. So we've been doing a lot of editing, right? So the first thing I want to do is I want to show you there's a catalog option. So if I go to second catalog, and there's a thing called clear all list. So my list is like crazy hectic. So what I'm going to do is I'm going to look for the green C, which is right up here. See this green C? If I hit alpha and then I hit this key, oh, I didn't do it. If I hit alpha, let me hit second. No, I'm going to hit alpha and then C. Oh, I didn't do it. That's all right. Let's try this again. I'm going to go second catalog. Then I think you just hit where C is. Yeah, my bad. So then I'm going to go down here to where it says clear all list, right there. I'm going to hit enter. Now when I hit that, what that does is when I go into stats and I go to edit, check that bad boy out. Remember all those data points that were in there? They're not there now. I just cleared them all. So I'm going to put the position. So we're going to compare the position, so it's just 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, to the distance from the sun. Basically, they're trying to say, depending on your position, there should be, they're hoping that there's a correlation, right, between the distance from the sun and your position from the sun. So now I'm going to plug in the actual data. So Mercury is 36,000 miles away from the sun. Venus, which is the next one, is 67 million miles away from the sun. The next one is Earth, that's us, 93 million miles away from the sun. Mars is 142 million miles away from the sun. 484, that's Venus, I think. No, wait, Jupiter? No, Venus was 2. I'm going backwards. And then Saturn is 887. Next would be, I love how they changed the name. It used to be Uranus, but now they say Uranus. Uranus is 17. It's 84, not 48. And then number 8 would be Neptune, which is 2796.
That's the wrong number.
Oh, did I type it? Yeah, I'll go back and fix it. Thank you. I gotta delete that 4, don't I?
Yeah.
So it's 1784.
Yep.
Okay. And then number 9 is 3707. All right, so now I've got to do a bunch of stuff here too. So I'm going to clear this out. I'm going to hit second y equals to get to the plots. And I'm just going to plot this in plot 1. So I'm just going to do L1, L2, scatter plot. So my first one is L1. My second one is L2. I'm going to hit zoom. Zoom stat was option number 9, and that's what it looks like. So now when you look at this data, this is not straight. Okay? This is not straight. So a linear model won't fit the whole thing. It's a curve. This is like the first case that I have written on the board. We have curved data. I can write a linear equation, but my residual plot will look kind of goofy. So I'm going to have to re-express this possibly. So let's jump back so you guys can see what I'm talking about here. Let's jump back here. And, oh, I forgot to copy that. So let me put that on here so we can see it better. I copied it, but I forgot to copy it. And then I'm over here and do this. So, and so what I plotted was basically I took the position and plotted against the distance of the sun. And when I plot it, I get this curve that goes like that. I can find a curve model to that if I wanted to, but what problem number 19 is saying is look at the data, re-express the distances to create a model distance from the sun versus the position. So to do that, we need to straighten the data. So to straighten the data, I'm going to take the log of the distance versus the position. So I'm going to do, let's go back into the calculator. And I'm going to take the log of the distance. So I'm going to go back into my editor. I'm going to hit edit. And to take the log of this, I'm just going to come here, and I'm going to put equals log, and then I'm going to put L2 because I'm going to, whatever the distance is, I'm going to take the log of that. And that gives me much smaller numbers. See what I did there? All right. So now I've got to do another plot. And I'm going to turn plot 1 off. Actually, I'll just switch it. So I'm going to switch this to L3 now. My Y parameter will be L3. Let me change the zoom on that to zoom stat. There we go. Now by taking the log, see how that straightened that curve out? I mean, that straightened it out tremendously. So let's take a picture of this so we could see them side by side. Let's do a linear expression because I think they ask us to do that as well. So I'm just going to, right now while I'm in this screen, I'm going to go to Calc, go to linear regression, L1, my Y list is L3. We're going to store that equation in, because I think we're going to need to do the residual. So I'm going to say vars, y vars, function y1. L1 to L3, store, calculate. Boom, there's my linear regression. Look at that correlation. The correlation coefficient is 0.99. R squared is 0.98. That's pretty good. So let's go back to the graph. There it is. I'm going to take a picture of this with the line. And how much time we got? We still got time. So it says re-express and create a model. So now we have the model and re-express. So this is the original data. This is the re-express data. And I'm going to label this. So this is basically the position. Number. Versus distance. Okay. And then where our re-expressed one is going to be the position number for our x-axis here. And then the only thing we did different is that we took the log of the distance. So log which you can see is much straighter and it has a tighter fit. So then our equation, our linear model for the log was that the log of the distance and we put the hat on that, so that lets us know that that's the predicted, is 1.245 plus 2.271 times the position, and we had an R squared value of about 98.2%, which is pretty good. So that's just part A. Now part B, it says based on this model, would you agree that Pluto is not a planet? Well, how do we say that? Well, when we first look at this model, it appears to provide little evidence to support this claim by astronomers. Pluto appears to fit the data. In other words, where's Pluto? Pluto's the last one. So let's talk about that. Pluto is this bad boy right here. And he appears to fit the data. So how could I tell if Pluto is a planet or not? How do we tell?
Like if it lines up with the predicted value.
Well, there's a better way. So Pluto appears to fit the pattern, although Pluto's distance from the sun is a bit less than expected, right? But then again, so is Earth's, right? So the model generated without Pluto does not have a dramatically improved residual plot. Right? It does not have a significantly higher R value, nor a different slope. So we can make a prediction, right? So let's do that. Let's use the model and make the prediction. So if I were to use this model, the log of the distance is equal to 1.245 plus 0.271 times the position. Pluto's supposedly the 9th planetary object. When I crank through the math, this is a predicted value, I get the log of the distance is equal to, when I crank through the math over here, this is about 3.65 241. So let me just crank through this on the, let's go through and do the residual plot on the calculator. I think that's the thing that would be helpful. So we'll go back in here. So I'm going to say stat, go to the list. I'm going to do L4. Now L4 is going to be my predicted value. So I'm going to enter in my model, which was 1, 2, 1, 2, 4, 5, 1, 2, 4, 4, 1, 8, plus 0.271229. So this is, I'm kind of skipping around, but 1, 2, 4, 4, 1, 8. This is the model if we omit the 9th position, which is very similar to the original model. I just forgot to show you where it comes from. But if I were to recalculate the linear model and omit the 9th position, we would get this model. So there's not as you can see, we're talking, it's basically the same model, okay? Or very close. It's off by 1,000th. So I'm going to multiply that by the position, which is L1. Okay, now to find the residual, I'm just going to take the actual value. I got to find the residual. So the residual is the y value minus the predicted. So this, in other words, I'm going to take L3 minus L4. So I'm going to say equals L3 minus L4. Okay. So those are the residuals. Okay. Now if I plot those, if I go to second, I'm going to plot, let's do the plot of the residual, which was, what was that, L5? Or no, the X is the predicted value, which is, what was the predicted value? L4, I think. Yeah. So I'm going to plot L4 versus L5. Let me do the zoom thing. Yeah. So that's right. So this is the residuals. Ooh, I got to hurry. This is a lot of work for one problem. Oh, we lost it. So that's the residual plot versus the predicted. So, and so for part B, it says, how do we, basically at first glance, so let me zoom out so you can see all the data now that I've got it all plotted out. So part B says, based on the model, do you agree that Pluto should not be a planet? So at first glance, this model appears to provide little evidence to support the contention. In other words, it looks like a planet. It appears to fit the pattern, although Pluto's distance from the sun is a bit less than expected. Now, what they mean by that is it's a little bit below the predicted value. A model generated without Pluto doesn't have a significantly different or improved residual plot and doesn't have a significantly higher r-squared value or necessarily even a different slope. So here was my original linear plot, which was the 1.24. The other one was 1.22. So if you omit, actually it wasn't 22, it was 24418. So it's off by 1/1000th. Same with the slope was in the original, it's 0.271. Guess what it was on the new one? 0.271. So Pluto doesn't appear to be influential. But don't forget that the logarithmic scale being used for the vertical axis, and higher up on the vertical axis, the greater the effect of the small change. According to the model, the 9th planet in our solar system is predicted to be, I got sidetracked. We got to finish what this prediction would be. So remember that the log of something is the common log, so that has a base of 10. So this is really equal to 10 raised to the 3.65243 number, right? Or 241, which is approximately 4,844. And then what is the actual value for Pluto? Well, Pluto is actually, I'll write it real big so you can see it, 3,707. So Pluto doesn't necessarily fit in, it doesn't fit the model at all, right? So when we look at it based on the scale and we do a bunch of the statistics, what it boils down to is we have to take the predicted value and compare it to the actual value. So if I were to do a residual plot of this here, you could see that Pluto falls short distance-wise, like significantly short, like 1,000 miles short, or 1,000 million miles short. And so that's what they base that decision on. Now, Pluto doesn't fit the pattern for position and distance in the solar system. In fact, the model made with Pluto included isn't a good one, because Pluto influences those predictions. The model without Pluto is a little bit different, and that works much better. So the new model that predicts the 9th planet should be a whopping 5,699 miles away from the sun. There's evidence that IAU is correct. Pluto doesn't behave like a planet in its relation to its position and distance. So basically, Pluto seems to be like an anomaly. Okay. Now there are other deciding factors. I think also is that the size of it it's so small they don't even consider it a planet. That might be why it doesn't fit the pattern. That might be why its predicted distance is way off, way far away. In other words, the residual for Pluto is significantly high or less. In this case, it'd be a significantly negative number, regardless of which predicted values you guys use. Does any of that make sense? Okay. But basically, we did a bunch of statistics work.